Hello, everyone. Can you confirm that you can hear me? This is a test to check if everything is okay. Thank you. I'm sorry because it's a bit noisy. Right now I'm not at home, but well, we are here to present our topic. It doesn't matter where we are, but yeah, we are here and we are glad to help. So I will turn off the mic a bit since I confirmed that you can hear me, and I'm pretty sure that you can also see the slides, correct? Okay. So, sure. Sí, correct. All right. So, thank you everyone for waiting, and we are ready. We are starting our session about Cosmos DB made easy with Azure Functions as part of the MSP Tech Americas event. Thank you very much for joining, all of you, and I hope that during this hour you learn a lot from this presentation. My name is Luis Beltran. I am a Microsoft MVP from Mexico. Currently, I'm living in Czech Republic because I am studying PhD. Well, I can talk a bit about me in the next slide, but yes, yes. I can. Sorry, I didn't understand. Ah, sure. Yes, yes. Go ahead. Go ahead. Yep. Okay, so thank you, Orlando, for the introduction, and welcome everybody to this presentation about Cosmos DB made easy with Azure Functions. I hope that during this hour you will learn a lot. My name is Luis Beltran. I am Microsoft MVP in Developer Technologies from Mexico. I was formerly a Microsoft student partner, So I'm really glad to participate in the MSP Tech Americas edition of 2019, which started last weekend with events in Brazil, Mexico, Nicaragua, and Peru from our colleagues, MSPs. So in this online session, I will be talking about a NoSQL database platform, which is Cosmos DB. And well, if you have any questions at any time, just let me know in the chat. This session is live streamed in two different places, so I will be checking both chats. Okay, so feel free to ask me any questions about the topic if you have any doubt. So as I said, well, I am from Mexico. I am currently a researcher at Thomas Batia University in Slin, which is in Czech Republic. I am finishing, hopefully, my studies this year, and then we will see what happens next. In Mexico, I was a lecturer or professor at Tecnológico Nacional de Mexico in Celaya. I mostly work with databases, programming, mobile software development, or particularly with .NET technology, C Sharp, and so on. So, yeah, my expertise is more about C Sharp, .NET, Xamarin, and of course databases. Here you can also see my email, blog, and Twitter account in case you would like to contact me after the session. So yeah, feel free to reach out. And let's get started with our topic. So, what is Azure Cosmos DB? Azure Cosmos DB is one technology from Microsoft. It's a NoSQL database platform which is hosted in the cloud, in the Azure cloud. It's a solution for particular scenarios such as global distribution of a database. You can see that we may have a database which is replicated or which is distributed in several regions, maybe North America, South America, Africa, Asia, and so on. The idea is that we can have such advantages like geo-replication of data, unlimited scale storage, because well, we can um, take advantage of each server or data center where we have our data stored. Another important thing about Cosmos DB is that we can access the information by using several APIs. Maybe a famous one is SQL API, so we can run SQL queries such as select star from the table, or we can also use JavaScript or table API. If you have worked with Azure table storage, it's more or less similar. But there are also other APIs such as Gremlin, Cassandra, or MongoDB, which is also a famous one. So it is up to you which one you would like to use. In the end, you have documents, you have collections, you have a set of keys and values where your data is stored, and you can perform CRUD operations such as retrieve information, add, update, and so on. But the basic idea here in Cosmos DB is that your database is distributed and is or can appear in several places. Okay, that's the main idea behind Azure Cosmos DB. And in this model, there are several advantages, such as global distribution, elastic scale out, low latency, consistency models, and the service level agreement. And we might talk about them in the next slides. So first of all, global distribution. As you can see, well, we can have our database located in or replicated in several data centers. We can decide to start storing our information in, let's say, West Europe data center. But then we might have a backup or another server, let's say, in North America. So in case that the server of West Europe has some problems, our users can still access the data because we have a backup server, or we have another data center where our information is stored. So we will not have, let's say, problems from our users accessing our data. So that's one of the advantages behind Cosmos DB model. Of course, it also implies that it will be a bit more expensive because now we are talking about two data centers, but in the end, it means that there is no failure in our service. So yeah, that's also another thing to consider. Um, Cosmos DB is particularly designed for environments where you have millions of data, a lot of information that you want to access, and maybe it's distributed by regions or by countries or by zones. If you have heard about distributed databases, you know what I am talking about. You know that there is, for example, horizontal distribution. Horizontal distribution is when you have your data, let's say customers at a customers table, and you want to partition your table. Let's say customers from Mexico, customers from Brazil, customers from Germany. So you have your whole customers database or table, but in Germany you will only access customers from that country. In Mexico, only Mexican customers. In Brazil, only Brazilian customers. So it means that we don't need access to the whole database. We can distribute, or we can partition our table only to the information that we need. Okay. It seems that there is a problem because I would like to ask if you can see the slides, because somebody told me that it's not available, but okay, I would like to ask if you can see my screen. Sorry for the interruption. Okay, so thank you for confirming this. Okay, so I will continue. Another advantage is that you can scale out your Cosmos DB database. What does this mean? It means that maybe at some particular time you need to assign more resources into your database. And you can see in this slide, for instance, that maybe you have a store, an online store, and during the year you have your customers, but you can expect that at some particular time, maybe at Black Friday, a lot of people, a lot of customers will reach your store. So it means that you need a more powerful server, more resources, you need much more memory to handle all these requests from the customers. So maybe only for that weekend or for those days, um, you will increase the resources in your database, and after these days you can return to lower resources. Of course, this impact the billing or the pricing in your um, in your Azure account, but it means that you can scale up or out as you wish. So this is also an advantage over, let's say, fixed hosting, because in fixed hosting you pay for some service, and maybe you don't need all these resources during the whole year, only at some particular moment during this year. So yeah, you can scale out your database at some particular time. You can do it manually, or you can also create some rules. So these partition or so these assignments are created automatically. And well, as it says in the slides, you can scale the storage from gigabytes to petabytes. So you can increase the storage or some other resources. Also, the latency is guaranteed. The latency basically means um, how much time it takes for your request to be processed. Um, Normally, when you make a request to your database, it will take some time from the server to process it. But see, if you have your data replicated, if you have considered several servers, it means that the the server which is closest to your region will um, will handle your request. So let's say I am right now in Czech Republic. If I make a request to a Cosmos DB database, and I have two servers activated, let's say one in Germany and the second one in Mexico, of course, my query will be processed in Germany because it is the closest one. If When I travel back to my country in Mexico, well, now the server in the US or near to Mexico will handle what I am asking for. Okay, so that's one of the smart, let's say, characteristics of Cosmos DB. So yeah, also we have the consistency models. Okay, this is a particular or special topic about Cosmos DB. It's not easy to understand, but I will try to explain it. Basically, the consistency means what data is shown to the users. Let's say that we have I don't know, let's say we have grades information from students, and a professor is updating these grades from students. So if we consider for our database a strong consistency, the students will obtain the latest update from the professor. Let's say the professor updates the grade of a student. It puts 50 grade. Then after 1 minute it updates to 60 because maybe there was a mistake, and 5 minutes after, the final grade of the student is 80. Every time that the student asks for the grade, it will query the database and will obtain the latest update. Let's say in the last minute it will be 80. That's the strong model. In the eventual, which is the opposite, in the eventual consistency, the students will get one of those updates. So it means that maybe when they query the database, they will obtain the 50 number, the first grade. And next time they um, ask for the grade, the result will be 80. So in the eventual one, it means that the updates are processed after some time. So basically, in the strong one, we are guaranteed that we are always getting the latest update, and the eventual consistency model is suitable for those cases where updates are not so frequent. Okay, if you need to add information or update information in your database, it is better if you use a strong or bounded staleness or even the session consistency model. Okay, so basically the strong one is when you need to update, you need to do a lot of updates. This could be called the hot updates. And if you are just reading information, the eventual is more suitable. Okay? Okay, I hope that this was understanding. Okay. And finally, the SLA means that basically you get service level agreement from Microsoft every time. 99.99% of availability. It means that your data will not be um, lost, and you will also not have like 500 errors that the data is not accessible or something like that. Okay, so basically the service level agreement is a commitment by Microsoft that your information will always be there for you. Okay, and well, this is because the architecture is highly redundant. It means that there are a lot of backups, there are a lot of elements involved, so you will always have your data for you or for your users. Okay, well, let's go a bit deeper about the resource model. How the data is stored in Cosmos DB? Well, first of all, we have something called the account level. When we create a Cosmos DB, we are actually required to create an account. Then in the account, let's say this is the general management, um, we we can create many databases there. Okay, it's a bit different, or let's say from the SQL model, the account would be the server. And then in the server we can create several databases. Okay. In each database, in each database, we can create containers. Containers would be more or less tables. Okay, and in each container we can create data or items. Okay, give me a second. Sorry. If you have any question, you can ask, but I'm just sharing some data.
مثلا کلا یه شرکت زنجیره یه شعبهش مثلا یه کشوری چند شعبه درش و اینو باید دسترسی داشته باشه به حساب مادر از حساب اصلا اونایی که اینا رو بر اساس اسکیول برقرار اینا چجوریه اینا یعنی تمام شعبات ست میکنن رو سرور یه دیگه سرور اون دیگه میتونن از همه جا دسترسی رو بکنن یعنی مثلا من اینجا بزنم میشم میگه میره تو حساب اصلی بعد اینجا بزنیم میره تو حساب اصلی تو آنلاین میره بالا مثلا میره میره سرور نشون میده مثلا چقدر تو حساب چجوری دیتیلز رو همه جا دسترسی داره ولی اونایی که برای نیست فقط تو از یه سیستم میتونی دسترسی پیدا کنی چون روی سرور نسبت نت نداره شبکه سوپر برنامه‌اش SQL سرور
Okay, I think I can continue. Right. So again, in the account, we are given an Azure website along with a secret or key for accessing the information. And then in the database, we can create containers. Containers, we can say that they are tables or collections or graphs, depending on the API that we are using. If we come from the SQL API or level, well, we know about tables. If you use Cassandra, you might have heard about graphs. If you use table storage, well, you know about tables, yes. But remember that Cosmos DB is no SQL storage, okay? So it's agnostic about schema. We will talk about it in a few minutes. And then in the lowest level, we have the data, we have the items, we have documents, we can also create stored procedures, triggers, or user-defined functions. And well, also handling the conflicts, like if there is parallel data which has to be written in a specific row, which one will be the latest update or something. Okay, so that's how the information is stored in the Cosmos DB. Okay, another important thing is the request units. The request units, sorry, is how the pricing works with the Cosmos DB. Basically, it means that if your query needs many resources, it will require many request units. And this has impact in your cost of the database. Actually, when we create a Cosmos DB, you will see that we can have some number. Okay, you are most likely to use, let's say, 400 request units, which means that the price will be 77 cents per hour or something like that. You will see it when I show the demo in a few minutes. But basically, when you are querying something from your database, let's say select star from your table, the server needs some memory, some CPU, and some input and output operations. So this has an impact in the price, okay, or the request units. Uh, you can have some request units when you are uh, getting information, when you are adding or doing a post request, when you are updating, and when you are even deleting. Yeah, you will consume some request units. Okay. Again, something also interesting about the Cosmos DB, as I said before, is that there is no schema. Basically, in Cosmos DB, everything is handled as a JSON content, as a JSON document. And you can see here, for instance, that we can have a container, let's say locations, and in locations we can have some properties such as country and city. But maybe there is a third location with a different structure. Maybe it only has a city, or maybe there is only a country. So uh, it's not like in the SQL where you have a table and every item inside the table has fixed columns like ID, or name, or last name, and so on. In Cosmos DB, you can have each item can have different properties. Okay, but of course, things are simpler if we have the same structure. Then we can have another entity called exports with property city, and this you can see in JSON. This is a collection. Okay, so each of them are an item or data, like Moscow, Athens, and so on. And you will see in the code, yeah, that it's quite simple to obtain this information. And well, a final element from this talk I already mentioned, but you can access your information by using several APIs. You can use MongoDB if you come from that storage. You can use Gremlin, which is based on Graph. You can use SQL or table storage, which is works with the key and values. So it's up to you which model, which API you would like to use. If you feel more comfortable with SQL, you can follow that API and write queries, SQL queries. If you feel better with graphs, with vectors, okay, you can use Gremlin API without any issues. In the end, the data is treated as this JSON document. Okay, and it's also important to say that several APIs are added each time. Okay, so I would like to ask if there are any questions at this point, because well, that's all the theory. Then I can show you a demo um, about the topic. So before that, I would like to ask if there are any questions or if you understood about it. There is also another topic, which is Azure Functions, but I'm pretty sure that you have already heard about it. Azure Functions is serverless computing or serverless processing, which means that we can write like code that will be available for let's say HTTP request, or maybe for time trigger and so on. And yeah, it will be in the cloud, and it will be available for us. Let's say if we are talking about an HTTP trigger, every time we request it, we will obtain the data. We are actually creating these triggers or these Azure functions in the demo. So yeah, I will explain about this topic in case that Azure Functions, in case that you have not heard about it. So, no questions? Okay. Well, if you have any doubt, just let me know. I will check the chat. Okay. Good. So, I'm sorry about this. Okay, so let's create a Cosmos DB in Azure. Oh, sorry. Then go here. So first of all, we go to create a resource, and we have databases section, and then Azure Cosmos DB. Mm, okay, we select a subscription. I think that's the one I need. I can create. Account name. I told you in previous slide that we will need an account. This is the first thing that we need in our database. Okay, so account name, Luis Beltran account. Okay, the API, here we have the ones that I just mentioned: SQL, MongoDB, Cassandra, and so on. I will stick to core SQL. Location, I will choose the one that is closest to me, which is North Europe. No georgency, no multi-region rights for the moment. And that's it. Okay. And let's create. Let's create it. Okay. Most probably it will take some time to create the database. So, okay, I will check again the chat in case that there are any questions. Okay, so give me a second. I will mute the mic for a moment because I know that it's a bit noisy here. I'm sorry about that because I'm not at home at this moment. But okay, while it is creating the database, please let me know if there are any questions. Okay, so I will be back with you in a few minutes after the database is created, but feel free to ask any questions about it, okay? Okay, in the meantime, I think I can explain the following. After we create the database, we will be adding a container and then some items. As I said before, these items are in JSON format. So I can explain maybe or share this part. We can actually add information from a file. Let's say we have this you have here the information. We are adding singer and songs information, okay? We have an ID, we have a name of one singer, and then a collection of songs. You might think about this in the SQL schema or format as okay, one singer can have several songs, so it's like one to n relationship. All right. In this case, you can include the elements or the collection inside one property of your data. Okay, so this is one item of the singers container. Sorry, the next item again has the same structure, even though it is not required. I mean, it's not mandatory that the elements inside a NoSQL database share the same structure. But in this case, for simplicity, I am doing that. So here we have the ID, the single name, and then again a collection of songs. And each song has song identifier and song title. Alright? And well, the same thing applies for the third element. Okay, and the database is still deployed. Well, and by using some queries, SQL queries, we can add, we can request information, and yeah. So I'm pretty sure that it is almost done. Okay, so let's say, yeah, the deployment is complete. So let's now go to our resource. And the next step is to maybe go to Data Explorer, and then we can add a container from there. So let's wait a bit. Okay, now let's add a container. Uh, let's say singers no, sorry, this is the database ID. So the database ID can be maybe music DB, container singer, container partition key can be slash singer ID. Something important about this is that it is let's say it takes into account upper cases and lower cases. So if I say that my partition key is singer with lowercase s, then that's the one I'm going to use here. All right. Okay, and then again we have the request units. The minimum is 400, but we can add more if we require them. Of course, this has an impact on the price. So we will leave the lowest request units, and that's it. Okay, the container has been created. Now we can go to items and upload some items. In this case, I will select the JSON file that I just explained to you and then upload it. In the meantime, let's see if there are any questions. No questions, okay. So it takes, yeah, 3 items have been created. And if I refresh this part, then you see that the information is already there. So this is one of the singers and a song. Okay, another thing which is worth mentioning is that we have an ID. This ID is used for internal purposes. We are actually using that ID for the update and delete function. Okay, so it means that it not only takes into account our, let's say, singer ID, but also an internal ID for this internal operation. This ID is automatically created by the Cosmos DB, but we have to take care about the data, singer ID, singer name, and so on. Okay, the rest of the properties are used for internal purposes. For instance, the e-tag is used to check if the entry or the item is updated or has to be updated. All right. We can also, let's say, sorry, not here. We can actually create a query. Give me a second. Okay, it's here. Yeah, new SQL query, such as select star from C, where C dot singer name equals to, for instance, and then you see the data. All right, and only that item, because it's the only one that complies with the condition. All right. So what else we can do? Now we can go to the Azure Functions part and then create these functions. Okay. So let's create a resource. Function app. The name of this one would be Cosmos DB demo. In the same resource group here, and I think we can leave the rest. Alright, now we can wait a bit, but not too much. The functions is quick. But in the meantime, I can explain to you this part, because, well, this is the code that we are actually using to retrieve information, to insert, to update. We have to create several functions for each of the requests that we would like to process. Okay, I will wait a bit. It won't take too much time. You give me a second. چرا بهت میگن چی اصلا تو میگی که واسه چیه گم می‌کنی 50% داری مالیات میگه که بستگی نداره چقدر مالیات بستگی نداره. Okay, it has been created. Let's go to resource. Okay, sorry, go to resource. Now let's create the function from the portal, continue, and let's use the template. In this case, I am using the ATP trigger. The name of the function is getSingers. And first we are integrating an input. This input is Cosmos DB binding, which you can see here. We have to install an extension the first time. We just need to click so the Azure Functions can see the Azure Cosmos DB input. In the meantime, we can configure the rest of the fields. The document parameter name can be, let's say, Singer document. This is something that we are going to use in our code, okay? So this can be whatever you would like to use. I will stick to Singer document. Database name is musicdb, is the one that we set up a few minutes ago. Collection name is Singer container. We also set that one up. And the connection, we have to create one and identify it. Is this one. Do you remember the account, Luis Beltran account? That's the one we are setting up. Alright, and we are not adding the rest. We are just waiting for these dependencies to be installed, and then we can save the information. So in this case, we are, let's say, creating a collection or a link to our Cosmos DB, the specific database, the specific container, and then we will retrieve information from there. Alright? So let's wait again and check if there are any questions. Okay, normally when there are no questions, either you have understood everything or nothing. So I hope that it's the first thing, that you have learned everything. Okay, we are still waiting a bit. Give me a second. Just to We are still waiting for the template to be installed. Actually, to be honest, this is the first time that it takes more than 2 minutes. It normally takes less time, but okay, for some reason it's now taking too much. I will just check that it's still working. I mean, in background, or maybe it has already been installed. I think so. I think so. Okay, good. So we can continue. In the get singers code, I will replace this by this information. Here you can see that we have our models, song and singer, which correspond or match the JSON format. Okay, here we have singer ID, singer name, and a collection of songs, as well as the ID, which I told you is for internal usage. Then we have song ID and song title. Then we have this function. Here I have to fix this one. This is singer document. This corresponds to the parameter that we mentioned in the integrate part. And also here, singer document. That's it. With only these 2 lines of code, we query the database and return it in JSON format. You can see it here. We can save this code and it should compile, and we can actually test it here. Let's run it. Okay, I think it is still installing the extensions because it's not working. So as I said, most probably the template is still being installed. So let me try something, okay? I will try to create a second function, again with the same code. It's singers 2, okay? I will add this code again. Of course, there will be some errors, but I will add the Cosmos DB again in this new function. Okay, this is singer document. This is music DB. Singers container, and okay, that's it. Save, and let's run it. No, it's still not working. Yeah, the Azure function app is down for maintenance. Yeah, it's because it is still installing the extensions. Okay, let's do this. I have another service which has these functions already created, so we can check those. Sorry, it's not here. It's here. Nope. Okay. Where are they? Yeah, here. So I have this function. Get songs, which has the exact same code, and if I run it, the information should be displayed here. You can see it here. Alright? It's the ID, the singer information, and well, I have other data. That's why you can see some different songs and singers. Okay, but the information is there because this is a different database. Okay, but the code is working. It's just that the other server or service is still installing these extensions. I don't know why. It's taking a lot of time, but okay. So this is the get songs, the insert song. I will explain the code. In the insert song, we have these namespaces. We have an out parameter, let's say some document, and in this case we are adding an entry from the request body along with a collection of songs. Alright? So you can see here the ID and title. So this request body is being processed in the Azure function. You can see it here, request body. Then this body is deserialized into a dynamic element. With this dynamic element, we are creating a new item from the singer container, which needs the singer ID, the singer name, and a collection of songs. If you remember the structure that we had here, okay, this is the singer table, singer ID, singer name, and collection of songs. Remember that ID is created automatically, all right? So after we create this and run with this information, you will see that it is created. Yeah, with status 200. Okay, right? I can simply, or yeah, I will add this example. I don't know. Travel. And this 1, 2, 3. The song is. Let's add it. Right? Yeah, I think. I'm not sure if it. Okay. Now I can check this with the get songs function. Let's run it. And let's check if El Chavo is there. Mostly at the end. Alright, I think. It seems that it was not inserted. Okay, let me quickly check. Oh yes, I remember. I'm sorry about it. It should be singer name with capital S and songs. Right now it should work. The problem was in the data. Sorry about it. Now let's check it again. Actually, you can check it here. Let's look for El Chavo. Yeah, there it is. Chavo and the song. La vecindad. Yeah, there it is. So it's working. And in this case, in the integration part for the insert, I did not explain that, but we just added an output, the Azure Cosmos DB output. It's not an input but an output, and but you know these parameters: music DB, song document, singers container, and the connection account connection. The same way we did it for the get songs. Then we can move to update singer. The update singer has this code. It's a bit more. I mean, it's larger than the other one, but basically, we again process a request body here. Okay, this is the element that we want to update. We have the singer ID, the singer name, and the songs. All right, and well, after we process this body and deserialize it into a singer element, we need to find that element inside the collection or the database. All right. So in this case, we are using the ID. Okay, I will speed up a bit because there is another session after this one. Okay, so basically, I am just querying the ID here, and we are updating the property singer name and songs. Okay, this is the update part with replace, and the delete is the same, except that we are not updating but deleting. Okay, again we are retrieving from ID and we are using the delete function. Okay, don't worry about the code. I will share it on GitHub. I will also share the slides. I will talk about a bit about it in a few minutes. Okay, so after we create these functions, for in each function we are getting an URL. Okay, so this is for the delete, this is for get songs. For instance, we can copy and then maybe paste it, and you get the information, the JSON element. Okay, so to showcase this part, I actually created a Xamarin mobile application. We have the endpoint, which is the one that we have, like here, MSP TechDays Functions, and then this is the second part: get songs, insert song, and this is for update and delete. So I just let's say split this function. All right, this is the base address. Well, actually until here the API. This is the base address and the rest. Okay, and calling these elements in the services. Yeah, function service. We have several methods here, such as add singer. Okay, we are just submitting the in the body the JSON element as you just saw. This is for the update, this is for deletion, and for getting the information. Here you can see get async, get singers async. So let's see it live in the application. The rest of the code is very basic. We have a list page and detail page. If you know about Xamarin, well, it's quite easy to implement it. So let's just wait a bit, and you will see the collection of songs here. Okay. Yeah, there it is. Some of them are empty, don't worry about them. So let's take a look about this singer. Okay, so I will change the name of this artist or group. I will just update it, save, and yeah, the name is updated. If I go to the database, let's say the one that I had before, because the other one it was not working. Let's quickly query it. Yeah, it should be this one. Yeah, you can see the new name, correct? It is also possible to add a new element like me. All right, no songs yet, but I am in the list right now, and you can see this is me. Okay, no songs, but I am in the list or in the database. Okay, so I know that this is very basic, but okay, this is just quick introduction to Cosmos DB with Azure Functions and also connected to a Xamarin mobile application. And yeah, maybe for the last part I can just delete an element, and this one is also working. Is also working. Yeah, it is not there anymore. Right? Well, I'm sorry about the problems that we had during the session, but I hope that you have understood anything. Um, if you have any questions about the content about the mobile application, just reach me out. Send me an email. In the next hours. Sorry, I will be updating or sharing this code into GitHub. This is my handler, icebeam7, and also in the YouTube or in Twitter, I will share the slides. Okay, so just follow me and I will share the information with you. Okay. So basically, that's all from me. Thank you for your attention. Thank you, Orlando and the MSP team for the opportunity to talk about this topic. And I wish you a good night wherever you are. And yeah, see you next time for the next topics. There will be some other sessions about cloud, data, mobile. I'm also participating in some of them. So see you soon. All right. So thank you very much. And if there are any questions, I will stay a bit in the chat. Okay. So yeah, that's it from me. Uh, I hope that you have enjoyed the session. Thank you.